So RIP was a good protocol to start with, but it really isn't a very good protocol. It has a lot of limitations. So what we want to do right now is we're going to go ahead and we're going to get rid of RIP and we're going to put in OSPF. And OSPF is the open shortest path first. Again, the first thing we're going to do though is we're going to get rid of RIP. So I've typed in enable, I did a show run, and let's look at our router RIP statement here. Now, so one of the problems with RIP is it doesn't send the subnet mask when it sends updates. And so, we put in two different network numbers here, but it doesn't understand classless interdomain routing. And so it reports back 170.32.0.0. Again, 170 being a class B address, and the subnet mask for a class B address is 255.255.0.0. So yeah, we put those two networks in. Those two networks are working correctly, but it just doesn't report that back. It's a little bit confusing, but there's a lot of other issues with RIP as a routing protocol as well. So what we want to do here is we're going to start out with, we need to get into global configuration mode, so we'll do configure terminal, and then we're going so we're going to do no router RIP. To get rid of our RIP configuration, we'll do router OSPF 100, 100 being our process ID. So we'll run the same process throughout our topology. We have a small enough network here. And we are going to do the same kind of network statements, but we'll actually add a couple of additional things. So we'll do network 170.32.64.0, and now we're going to put what's called a wildcard mask, and the wildcard mask is actually the inverse. It's actually the inverse of the subnet mask. So we'll do 0.00. We'll do 0.00.255, and then OSPF allows you to put multiple areas, so you can break down the network into smaller pieces. Ours is going to be a single area OSPF, and so if you have single area OSPF, the primary area is always called area 0. So we're going to go ahead and put in 64 and then 58, and we're going to do a copy, run, start to save this. Okay, so that was our Fremont internal router. If we come up to our Fremont edge, and we're going to do enable, and we'll do configure terminal, and we're going to do a do show run, and we have our router RIP statement there. We're going to do no router, and we're going to do no router RIP. We'll do router OSPF 100 network 170.32.64.0, our mask of 0.00.255. And all of this is in area 0. And in addition to 64, we are going to do 56. So that probably looked a little bit confusing here. I'll do that statement again there for you, because we're getting messages right in the middle of that. Okay, so now I'm going to go ahead and configure the rest of this, and then we'll come back and we'll determine whether or not we can ping across the network. Okay, so here we are on the Fremont internal router, and again, I'm just going to hit a couple of devices to check to make sure that we can get across the network. And so we're going to end here, and let's do ping and 170.32, and let's pick something like 118.1, and that is on the Vance router, so that's really far out there. And then we'll actually do up on the Dearborn router, we're going to do 18.1. So we, for both branches of the topology, we can get all the way through. Obviously, you need to check every single router to make sure that it's working. I do want to talk about showing that your router is participating in the OSPF network. And so we're going to do show IP route, and if you look here on the left hand side, we see all the different networks that it's learning via OSPF, and then if it says C, that means it is directly connected. So if you look here, you can see that these two are directly connected, and all the rest of these is learning via OSPF. Okay, that's OSPF configuration.